Okay, so in our previous video, I left you with this problem and asked you to work this one on your own, where you identify the intercepts and you graph this equation. So if we're going to find the y-intercept, again, that's the easiest one to start with. So we're going to take 0 and put it in for x. And when you do, we have negative 3 times 0 squared minus 2 times 0 plus 1. And what you'll notice is that 0 squared is 0, and 0 times negative 3 is 0, and negative 2 times 0 is 0 plus 1. And 0 minus 0 plus 1 is obviously 1. Now, what it tells us is that our y-intercept is 0, 1. Okay, that's going to be a point that we can graph in just a minute. Now, the x-intercept we find by putting 0 in for y. And again, that f of x is equal to 0, or is equal to y. So we're going to write an equation that says that 0 is equal to negative 3x squared minus 2x plus 1. And so we'll just solve that quadratic. And because that first number is negative, it'd be easiest to factor out a negative 1 as a greatest common factor. When you do, that's going to change our signs. And the reason we do this is because we don't want to do bottoms up with a negative. That becomes kind of an issue, and so just to keep us from having to deal with that, we're just trying to find x. We can factor the negative 1 out. So keep it factored out. We're going to do bottoms up. Multiply 3 times the negative 1. We have x squared plus 2x minus 3. And then we're going to factor that. We're looking for two numbers that multiply to give 3. That will subtract to give 2. Which will be 3 and 1. Signs are different. Biggest number gets the positive. And then, because we multiplied by 3, we'll divide by 3. And so what we find out then is that x plus 1 is one of our factors. And that 3 gets moved up, and it becomes 3x minus 1 is also a factor. And so, again, remember to solve, we're going to take each factor and set it equal to 0. Well, negative 1 can't be equal to 0. And so there's no purpose in writing that out. We only want to write the factors that have an x in them equal to 0. So we're going to say that x plus 1 equals 0. And 3x minus 1 equals 0. And then solve. And so when we do, we'll find out x is negative 1. And in the other equation, we'll add 1 and divide by 3. And we'll get x is 1/3. And again, we're looking for the ordered pair. So it's negative 1, 0. And 1/3, 0. And so now we have 3 points that we can plot that should be enough to give us our curve. And so as we plot each of those, the 0, 1 says we don't go right or left any, but we go up 1. And notice here that because this is a negative leading coefficient, this parabola is going to open down. And it's going to be fairly narrow because that 3 is bigger than 1. And so it tells us that it will be stretched vertically, which makes it more narrow. So when you plot your x-intercepts, negative 1, 0 is that point. And 1/3, 0, let me zoom in so you can see where that would go. 1/3, 0 is going to be around that point. Now, you can tell that if you just were to connect those points, it's not symmetric. And so what it tells us is that our vertex has to be somewhere in this area. Now, we don't know exactly where it is. We could find it. We're not going to yet. But we know that the vertex has to be somewhere above this point. Because if it's going to be symmetric, the middle point between this one and this one, between our two x-intercepts, is somewhere in that area. And so if you were to take that line of symmetry up, you would see that you end up with a point somewhere in this area, which is where our graph would be. Now, let me erase some of those extra marks, and let's look at this graph. So we have these 3 points. When we graph this line, or this parabola, we're going to go a little bit above that point and then back down. And again, you can see that's fairly narrow. It does go through each of those points, and it could be that that vertex actually should be a little bit higher, but we don't know exactly just based off the intercept. We do know that it is somewhat above that y-intercept. And so graphing with the intercepts is not the easiest way necessarily, but it does allow us to get an idea about what the graph should look like. And so we can see that in this example. So we mentioned that if the quadratic function is in this form tells us a lot of information. It tells us how the parabola is shifted left and right, how it's shifted up and down, if it opens up or down, if it's narrow or wide. And all that information can be found by the A, the H, and the K. The H and K, right this way, H and K are the vertex of our parabola. Okay? Because think about in that parent graph that starts at the origin, well, when you shift that point right or left and up or down, well, now that vertex is at a different point, right? And so that H and K tell us the vertex. So if we can find those 2 points, great. And if our equation is in this form, that's really, really helpful. But a lot of times our equation is going to be in this form. And if it's in that form, then it's not very easy to identify H and K. And so we have what we're going to call the vertex formula, which says this. This is how we're going to find our x-coordinate of the vertex. That is to take a negative b divided by 2a. So you can see your b and a there from the original function. So negative b divided by 2a, and that's going to give us the x-coordinates of our vertex. Okay? Then once we know that number, we can put that into the function, and we can find our k value. Now, understand also that this vertex formula actually is going to give us the equation x equals something, and that's going to be our line of symmetry. So our line of symmetry is x equals this negative b over 2a. Okay, that's going to be important because I'm going to ask you in just a minute for a line of symmetry, and I'm going to ask you to tell me the vertex. Well, if you can identify where that x-coordinate is, and you can substitute that in, well, that's going to give you the y-coordinate of the vertex, it's going to give you that point. If you were graphing, you could go right and left of that and very easily be able to graph any parabola that I could give you. Okay, so let's take all of that and let's apply that here in our next slide. So we've mentioned all of this. You can see all of this pretty easily. The graph of our function has the following characteristics. The parabola with the vertex HK and the vertical line x equals h. Again, that's that line of symmetry. This is the equation for the line of symmetry every single time. X equals whatever this x coordinate is from our vertex. Okay? The function is going to open up if our a value or leading coefficient is greater than 1. or I'm sorry, greater than 0. I was thinking wider versus more narrow. It's going to open up if it's positive. It's going to open down if it's negative. If it's wider, then our absolute value is less than 1, between 1 and 0 of that A number. If it's more narrow, that number is bigger than 1. Now, one thing you may have noticed that I haven't said yet is number 4 here. If you want to find the x-intercept, it's always your constant value in your quadratic formula, or quadratic equation. For example, if you go back here, the first thing we did was find the y-intercept. Okay? And we put in 0, and you'll notice what happened is 0 squared times negative 3 was 0, and negative 2 times 0 was 0, and all that's left is that constant number, because there's no x, no 0 to multiply by. And so because of that, if we know that when we put in 0, all those x's but basically just go away, then all that's left is this constant number. And so our y-intercept is going to be that number. It's 0, comma, whatever that constant number is. And so that's what point 4 says here. And then point 5, and we're not really going to get into this much, but the x-intercepts are found by solving the quadratic equation. Okay, and we've done that. Again, we did that on those last few problems that we've talked about. These 3 things at the bottom, we're not really going to address a whole lot. I'll mention them here just because in our quadratic formula, and you can see the quadratic formula is written here to the right. In that formula, that stuff that's under the radical, b squared minus 4ac. If the b minus 4ac is greater than 0, then we can solve that quadratic equation and find our x-intercepts. If we are, if we get that is equal to 0, then our x-intercept is negative b over 2a, comma, 0. If that happens to be less than 0, then there's no x-intercepts. It means that your solutions, your x values, are imaginary numbers, which means that the graph does not cross the x-axis. And again, we're not going to see that much. It's just something to mention. And so our last thing that we need to do is we need to take this equation. We would need to find the axis of symmetry and the vertex. To do that, we're going to use the negative b over 2a to find the x coordinate of the vertex, also the axis of symmetry. So in this case, the 2 is the a, the 4 is b, the c is 5. And so if you take those values and you put them in, so this h is equal to, h being the x coordinate, is equal to a negative 4 over 2 times 2, and negative 4 on top over 4 on the bottom. Negative 4 divided by 4 is negative 1. And so what we find is that the axis of symmetry is x equals negative 1. That's the x coordinate. And then we can also find the vertex by taking that negative 1 and putting it in to the function. So when we put it in, we have 2 times negative 1 squared plus 4 times negative 1 plus 5. And then we're just going to simplify. Again, following order of operations, negative 1 squared is 1. 4 times negative 1 is negative 4 plus the 5. And then 2 times 1 is 2 minus 4 plus the 5. So 2 minus 4 is negative 2. Negative 2 plus 5 is 3. And so our vertex then is negative 1 comma 3. And so there's our vertex. and we had our axis of symmetry here.